Welcome, Geometry Excel students, to lesson 4.6. So in this lesson, we're going to go over congruence and overlapping triangles. And first, we're going to talk about CPCTC. Okay, so what it stands for is corresponding parts in congruent triangles are congruent. Okay, so when do we use CPCTC? When we are asked to prove that parts are congruent. But first, before we can say that parts are congruent, we must prove that the triangles are congruent. Okay, so in this figure, we have a rectangle. We have the right angle markings, and we have congruency markings on AB and DC. The diagonals of the rectangle are AC and BD. So why is it important to identify corresponding parts of overlapping triangles? So one thing you might want to do, sometimes these diagrams can get pretty confusing. So you might actually want to separate the two triangles and relabel them. So this triangle is triangle ABC with B as the right angle. And my other triangle, this is DCB with C as my right angle. So again, we had congruency markings here and here. We've got the right angles. And in this particular case, for these two triangles, the overlapping part, or the shared part, is side BC, which we know that any segment is congruent to itself by the reflexive property. So it's important to identify these parts so that we can determine first if the triangles are congruent, and if they are, by which theorem or postulate we can use to say that they are congruent. So what are the corresponding sides and angles in triangle FHJ and triangle KHG? So again, I'm going to separate my triangles. Whoop. Grabbing the wrong thing here. I'm going to put them over here and relabel them. Okay, so again, here I have markings on angles F and K that show me that those angles are congruent. And then I also have congruency markings on FL and KL, and also GL and JL. Now, if I have congruent parts and I add congruent parts to them, I get another set of congruent parts. So that tells me that FJ is congruent to GK. Okay. Now, I also have angle H in both triangles. Okay, that's a shared part. Okay, or I would call it a shared angle in the two triangles. So of course, again, by the reflexive property, H is congruent to itself. So I know these two triangles are congruent by AAS, and then I could start listing out the congruent angles and sides, right? So angle F congruent to angle K, angle H congruent to angle H, and angle G congruent to angle J. It would probably be better let's see, when we look at this, I'd probably say FJH. So angle FJH is congruent to angle K, angle symbol, angle K, GH. And I could follow that same order to say the two triangles are congruent. Okay, so that would be one pair of angles. We'd have angle H congruent to itself, again angle F congruent to angle K, and then I could start listing out sides. FH congruent to KH. Let's see, FJ congruent to KG. And finally, let's see, what am I missing here? Oh, I can say that HJ is congruent to HG. Okay. Okay. So in this diagram, we're being asked, is angle EGD congruent to angle EFH? So again, I'm going to separate these two triangles. Oh, I'm missing a side there. Okay. And that makes this DEG. And the other one, this is E, H, and F. So notice we have overlapping here with FG. Okay. So we're given that DE is congruent to EH. We're given that DF is congruent to HG, which again, by the same idea we used over here, if I add FG, which is congruent to itself, to both of these congruent parts, that tells me that DG, I'm just going to use a single marking here on this diagram, is congruent to HF. Okay, now there's one more thing here. If you notice in the large triangle that we have a pair of congruent sides, which makes triangle DEH isosceles. So I also have angle D congruent to angle H. So the two triangles are congruent by side angle side. So angle EGD is congruent to EFH. Oh, trying to put a double marking on there for that one. So the answer is yes. Okay, and that's how we use CP-CTC. Once we say that the triangles are congruent, any corresponding parts are then congruent. So I want you to try this problem. Pause the video and determine if VW and ZY are congruent, and then write a little explanation of why you think they are or why you think they aren't. When you're done, come back and we'll compare solutions.